Hello, my name is Mojeed Ashaleye and I'm from the Dade College North Campus. I did this research project with the following mentors. They're Professor Justina Castellanos, Professor Angel Perez, and Professor Lourdes Gonzalez from the Kendall campus. I also did this research project with a partner who presented the first part of this research project. And the second part of this research project focuses on the usage of L-curve and singular value decomposition in image compression. And the reason why images are used is because the pixels in images, they can easily represent the matrix values that are present within images. And another reason why images are used is because the visual quality of an image can be easily preserved no matter the magnitude of reduction in singular values or data. Another reason why is because no matter what format an image is saved in, the pixels in the image will always represent the matrix of their values, as stated before. In conjunction with working with singular value decomposition, the similarity of the original image in comparison to compressed images were tested using a similarity coefficient known as structural similarity index. And this coefficient ranges from a value of 0 to 1, with 1 being a perfect match. In addition, the percent compression was also looked at, and this looks at the number of singular values in the corner of the L curve, which is what we seek to use in the compression of images. And as mentioned before, the goal of this research is to test the effectiveness of using the L curve in detecting the number of singular values or data that are present in the images, and that also represents a balance between image quality and storage saving. Essentially, this research is trying to find a way to compress images while using less data as possible, and at the same time, um, you know, creating images that can be easily manipulated by, reducing their file size and therefore saving storage. And this method was carried out with a program known as MATLAB, in which the images were read and then they were transferred to grayscale if they were already in color, and the singular values of the images were computed along with the usage of the triangle method, which calculates the corner of the L curve, which is essential as opposed to using the number of singular values in the images, which will only be time consuming. And the reason why this is done is to avoid having too many points on the L curve. And once the corner of the L curve is found, this will be approximated to the matrix of the original images, which therefore represents the best balance between image quality and low storage. And this was all done with 118 images downloaded from the internet and some that were personally taken. And over here, you can see that in the results of numerical experiment, here are some images that stood out in terms of structural similarity index and percent of compression. So these images, they show impressive amount of compression and impressive amount of quality preservation. And here in this image, in the moon image that's saved in the format of a JPEG file, it has a structural similarity index of 0.99561, while at the same time having a percent compression of 88.655%, which is pretty impressive, which shows that the usage of singular value decomposition and the corner of the L curve were effective in compressing images um, while at the same time preserving quality. And over here in this image title 2 that's saved in the format of a JPEG, it has a minimum structural similarity index of 0.63519, which isn't bad. It's pretty close to 1. And it has a percent compression of 64.3272, which is over half, and it's still pretty decent. And the maximum percent of compression that is found is an amazing 96 or roughly 97% compression. And it has a structural similarity index of 0.96715, which is very outstanding. And the least compression that is found, or to say the worst, is in the tree image, which is saved in the format of a JPEG file, because there wasn't much that can be done. The trees contains leaves and the pixels were scattered all over, so it was very hard to pinpoint which exact pixels to reduce and how to correctly gather any data or singular values. But however, it still has a structural similarity index of 0.7, which is close to 1, so it still retains its quality regardless of the poor um, compression. In conclusion, the development of the L curve of the number of singular values was actually effective in providing compressed images while at the same time um, providing images with preserved quality. And this is more effective as opposed to using all the corresponding singular values in the images. And this was all done in the software known as MATLAB, which shows the original image, the L curve, and image that only uses the number of singular value in the corner of the L curve. And this was all performed with 118 images. And this procedure was actually automized in terms of, critical decision making problem on how many singular values are enough for both saving in storage and image quality, which was the purpose of using the corner of the L curve in singular value decomposition. So this shows that singular value decomposition and the corner of the L curve are effective in compressing images while at the same time preserving their quality. I would like to give a special thanks to the mentors, Professor Castellanos, Professor Perez, and Professor Lourdes, and to the Miami-Dade College School of Science. Thank you very much. Without this presentation would have never been possible. Thank you so much and have a great day.